So the problem we have right now is a man throws a shot at an angle of 45 with a horizontal plane from a height of 1.5 meters. If the shot strikes the ground at a horizontal distance of 30, find the velocity of throw. So a person is throwing something with a particular velocity which is unknown, but it is making an angle of 45 to the horizontal. So it is going to hit the ground 1.5 meters below because the object was projected at a height from a height of 1.5 meters. So this is going to be 1.5 meters. And it hits the ground at a distance of 30 meters from where it was thrown. So we know that any projectile motion has two components or two projections. So the horizontal projection is going to have a horizontal component of the velocity of the initial one, and it is going to travel a distance of 30 meters. And the acceleration in the horizontal direction is 0. Meanwhile, if we consider the vertical, it is going to go up and then come down. And the initial velocity in the vertical direction would be the vertical component of the initial velocity. And the acceleration due to gravity for the vertical component would be, and we are supposed to take 10, right? And this is 1.5. So it is 1.5 inches. So the horizontal component and the vertical component are going to be V cos 45, which is V over root 2, and V sine 45 is V over root 2 as well, because sine 45 and cos 45 are 1 over root 2. So let's deal with the problems. So I'm going to consider the vertical projection first. So for the vertical projection, I'm going to apply delta y equals to VIT plus half AT squared. I'm going to consider anything downwards as positive. So the object is ultimately coming down from where it was thrown, so the displacement is downwards. And I'm considering anything down as positive, so it is 1.5. Initial velocity is v by root 2, but it is pointing upwards. I'm considering anything down as positive, so it is negative v by root 2. And time of flight I do not know, plus half. Acceleration due to gravity is pointing downwards, so it is positive, and it is t squared. So that is going to be my first equation. I can do a little bit of cleanup there. So that is minus v over 2t plus 5t squared. So that is going to be my first equation. And just by looking at it, we cannot do anything in that equation because it has two unknowns. So let's use the horizontal projection. So for the horizontal projection, we know the time. So for the horizontal projection, the horizontal displacement, I'm going to use the same equation. So delta x equals to VIT plus half AT squared. I'm going to consider anything from being right to the right as positive. So the displacement in the horizontal direction is 30. Initial velocity is v by root 2, and the time is t, and that is 0. So what we can do right now is, I can say this is my second equation. So I do have the v by root 2t in the first equation there. This part is right here. So what I can do is I can substitute for that part. So I will get 1.5 equals to minus 30 plus 5t squared. So this will go to the other side. So we would get 30.5 equals to 5t squared. So t equals to square root of 30.5 divided by 5, which is square root of 30.5 divided by 5 is 2.5 seconds. So the time of flight is 2.5 seconds. We need to find what the v is. So I can substitute this back in this equation, and I can find the v. So 30 equals to v by root 2 times 2.5. So v is 30 root 2 by 2.5. So that is 30 square root of 2 by 2.5, which is 16.97, so I'm going to consider it as 17 meters per second, right? If you have any doubts, please ask. Otherwise, take it down and let me know.